Hi guys, today we're going to talk about rational functions. I want you to be aware of some of the characteristics of rational functions, where vertical asymptotes may be, where you may have a horizontal asymptote, maybe you don't have any horizontal asymptote, and then discussing the domain and range. So the goal of this video is to just make sure that you can identify different characteristics of these types of functions. Okay, so first, if you look at this graph right here, I've given you the function, and then this is what that function creates if you were to graph it. What we want to do is find out, well, how, without using our calculator, how would we know that there was a vertical asymptote here, and how would we know that there was a horizontal asymptote there? Also, if there's any places where it crosses the x-axis, it looks like right in here it may cross the x-axis, we want to know, well, how could we determine where it crossed the x-axis? Okay, so if you want to find the vertical asymptote, there may be more than one vertical asymptote, but in order to find the vertical asymptote, you solve the denominator. The denominator is the bottom part of the fraction, okay? If, for some reason, when you're solving the denominator, if you have a factor in the bottom that cancels with one in the top, then that's a whole, and it will not be considered a vertical asymptote. All right? If you want to find the zeros, where does the graph cross the x-axis? Okay, then if there are any, you will just solve it by the top, setting the top equal to 0 and solving. So solve the numerator. And of course, if there is a horizontal asymptote, then this is a phrase that I was taught a few years ago that really has helped me figure out how to determine where the horizontal asymptote is. And you say, Bobo Botten eats DC. Bobo Botten eats DC. And so what you do is you're going to compare the degree, the exponent on the top, the leading coefficient's exponent, compare the degree of the polynomial on the top to the degree of the polynomial on the bottom. If it is bigger on bottom, then you'll have an asymptote at y equals 0. If it's big on top, you have none. So get Bo, right? That's big on bottom, 0. Botten, big on top, none, Botten. And then eats DC. If the exponents, that's referring to the degree, if they are the same, we'll divide the coefficients. So, taking a look at this original problem here, we have an x squared and another x squared down here. We're only looking at the degree of the polynomial, so a 2 and a 2, okay? So they're both quadratics. In this case, exponents are the same, so we would divide the coefficients. The understood coefficient here is a 1. So I would have a horizontal asymptote at y equals 1/2, 1 over 2. Divide those coefficients. This is big on bottom, so up here I have a degree of 0 because there is no variable, which means there's no exponent. So the degree is 0, that's a constant up there. And then down here I have a degree of 2. So 0 and 2, if you compare those, it's bigger on bottom than it is on top. So big on bottom, y equals 0. And then of course over here I have a 2 on top, a degree of 2, and then this is linear down here because it's a degree of 1. So bigger on top, big on top, none. So there is no horizontal asymptote, and as you can see, there's none drawn here. Okay? Alright, so the domain, of course, is always affected by your vertical asymptotes because it creates a barrier that cuts off the x-axis. Okay, and then the range, of course, will be affected by a horizontal because anything horizontally will cut off the y-axis. All right, let's try one. In this problem, we are going to determine the zeros. And let's see, first let's determine the zeros by setting the numerator equal to 0 and solving. So to find the zeros, we're going to say x cubed plus x squared minus 2x equals 0. And this, of course, we are finding zeros. So we're going to factor out an x, get x squared plus x minus 2 equals 0. Of course, we can have an x equaling 0. Or let's factor the rest of this. X. Okay, we need a 2 and a 1 to make 2. And we need this one to be positive, this one to be negative. A positive 2 times a negative 1 will give us negative 2. And a positive 2 plus a negative 1 will give us a positive 1x in the middle there. So then we'll have x plus 2 equals 0, x minus 1 equals 0, x equals negative 2, and x equals 1. Alright, so far that's what I get when I factor it out. I'm going to just write all of this up here. X times x plus 2 times x minus 1. Alright, over. Now before I say that these are officially the zeros, I need to make sure that nothing's canceling in the denominator with it. Okay, so I'm going to erase this work here, make sure that you have it. Erase this work. Okay, and then I need to determine the denominator. Now the denominator will tell you your vertical asymptotes. Okay, so to get my vertical asymptotes, I am going to take out a 4 first, and I will have x squared. I take out a negative 4, by the way, and I'll have minus 2x minus 3 equals 0. I'm going to keep factoring. Negative 4x, and we'll have a 3 and a 1. 3 and a 1, because that's the only way to multiply to get 3. I need to create a negative 2, so I'm going to make negative 3 plus 1. That would create a negative 2. Alright, so this is the factored form of the denominator. So I'm going to go back up here and rewrite it. Negative 4 x plus 1 x minus 3. That's the factored form of the denominator. Now, what we look at in the denominator, our factored form gives us our vertical asymptotes. Any x value that you can solve for, that's what you need to do. 4 does not have, this negative 4 doesn't have an x with it, so you're not going to set it equal to 0. But for your vertical asymptotes, by the way, if you compare all of the factors up on top with all of the factors on the bottom, there's none of them that are the same, so nothing cancels, which means there's no hole in the graph. Alright, so for my vertical asymptotes, I'm going to set the x plus 1 and x minus 3 equal to 0 because I don't have an x here. So if I do that, I'm going to get x equals negative 1, and I'll have a positive 3. And by the way, that was from x plus 1 equals 0, x minus 3 equals 0, and solve. And these are the two vertical asymptotes that you'll have. Okay, so at negative 1 and at 3, x equaling them, that's vertical asymptote. Alright, for your zeros, the zeros, I was waiting to see if anything would cancel before I wrote down officially what the zeros are. I'm going to set x equal to 0, x plus 2 equal to 0, and x minus 1 equal to 0. And all three of those, once I solve, those are all officially my zeros where the graph crosses the x-axis, the x-intercepts. So at x equals 0, -2, and 1, or you could write this, since they are hitting on the x-axis, the y values will be 0. So that point, -2, 0, and 1, 0. Okay, all of those are the zeros. And then the last, well, not the last thing, but you also want to be able to find the horizontal asymptote. The horizontal asymptote, we look at the degree. This is a degree of 3. This one's a degree of 2. So the polynomial is in standard form. This is the highest degree. So it is therefore the degree of the polynomial. We have bigger on top. Big on top. So Bobo Botan. Botan is big on top, none. Big on top, none. So there is none. There's no horizontal asymptote in this problem. Okay, so if you were to graph this and you have vertical asymptotes at -1, we'll say that's at -1 and at 3. Okay, this is at x equals 3. This is at x equals -1. That's cutting off your x-axis. Okay, so you could write for your domain, you could write the domain is a set of x such that x cannot equal -1 and x cannot equal 3. You could write that. Or you could do something like from -infinity up to -1, and don't put a bracket, put a parentheses, union that with -1 to 3, both in parentheses, and then union that with 3 to infinity. That's if you want to do it all like that, but I would just maybe write it like this. It seems a little bit easier, but you can do it the other way. The range, well, nothing cut us off horizontally. Nothing cut the range off, so it looks like we can use all real numbers. All right, let's try another problem. Okay, here we have, we're going to go ahead and factor out this top part, x times x minus 1, and factor the bottom part, x and we need 6, and because I'm needing to get a -1 here, I'm going to do the 3 and the 2. 3 times 2 will give me 6. I need it to be -1, so I'm going to pick the higher value to be negative, and this will be positive. All right, and then we check and see, will anything cancel? Nothing cancels, so there's no holes. To find your zeros, set the numerator equal to 0 and solve. So we will have x equals 0 and x minus 1 equals 0. So we would have a +1. That's where it crosses the x-axis. To find our vertical asymptotes, we set the denominator equal to 0 and solve. So x minus 3 equals 0 and x plus 2 equals 0. We would end up with a vertical asymptote at x equals 3 and at x equals -2. And then to find our horizontal asymptote, you look at the degree of each polynomial. So they're both 2. They're the same. This is the eats DC part. So Bobo Botan eats DC. Big on bottom, none. Big on bottom, 0. Big on top, none. Eats DC. Exponents are the same. Divide the coefficients. Coefficients are the numbers out in front. Well, this is understood to be 1, and this is understood to be 1, so 1 divided by 1 is just 1. There is a horizontal asymptote at y equals 1. Okay? And so, therefore, if the horizontal asymptote is at y equals 1, and then we have two vertical asymptotes, one at -2, this is at x equals -2, and one at 3, x equals 3. then the domain is cut off going this way. It's cut off at -2 and at 3. So for our domain, let's see, for our domain, we're just going to say the set of x such that x cannot equal -2 and x cannot equal 3. And for our range, well, the horizontal asymptote is what affects our range. And we do have a horizontal asymptote here at y equals 1. So as I'm going up, I'm going to have to skip over that line right there because there's an asymptote there. So the range is the set of y such that y cannot equal 1. Okay? That's the characteristics that I want you to know, and ask me questions if you are unclear on anything.